Hi, and welcome back to the Survivor series. It's been a while since we posted a video for a couple of reasons. One, participated in the Titan Art Jam that Epic put on. So that took me away for about 10 weeks of really focusing on gameplay mechanics. And two, I got a new computer and it ended up being an i9 Intel chip. And if you've looked at the press, there has been a lot of crashes with that particular chip, my rig included. So I had to go through some troubleshooting and changes. So that took me out for a little bit of time as well. But we're back, we've got our system stabilized, and we're pushing forward. So in this video, we're gonna cover some significant changes to the survival mechanics. Basically, we've switched from our custom climate system that we did in videos past to using ultra dynamic sky and weather. It's a far superior system, and it's just a realization that it would take months and months, if not years, to replicate that. And so it's just much easier to use that plugin. So we switched over to that plugin. Props to that team that has developed the ultra dynamic sky and weather. It's a great plugin. We've done some improvements in our UI, so we'll walk through some of that. We've added heat sources and we've implemented food. So on this reboot, this is a relatively short video. We're just going to walk through how we've done each of those elements. So as I said, we're from this point forward, ultra dynamic sky. We've also switched to substrate materials, which is experimental, but will allow layering. And there's a few little glitches right now that we're working through on that. But we decided to make that switch. We've connected our weather and seasonal system through Ultra Dynamic Sky to our survival attribute set. We've changed the icons and leveraged a Lyra base material, so we'll show you that in a minute. Enabling our food and drink system from inventory with a couple of different options on how to replenish your food or drink. And then the radial heat from various fires to ward off environmental effects. So first, let's talk about just how we quickly converted from our climate system to UDW. If you use the UDW plugin, it will install by default into your content folder. And so since this is a Lyra project, we don't want to leave it there. We actually are moving it to our own game feature. And the steps were pretty simple and seems to, at least through testing, to work quite well. So we added the UDW plugin to the project, which creates its own folder in content. We then went into the editor, created a game feature, excuse me, and then saved the data asset that shows up by default, exited Unreal, and then used File Manager to basically copy all of the folders in totality over to the new game feature. That way we don't create redirectors. So if we did this in editor, we'd end up creating a bunch of redirects. We could break material to texture linkages. So it was much easier and much cleaner to just pick up all of the files in your favorite file manager, move them into the game feature folder, and then relaunch the editor and test your demo map to make sure everything happened successfully. So we went through a couple of iterations of making sure that worked the way we wanted to before we pushed any further. And then we added the dependency of the new game feature to our climate core game feature. So it basically sits underneath that. And then we will be stripping away all the climate core features that are duplicative with the ultra dynamic weather. The next thing we did is adjusted our survival themed attributes. If you watched earlier videos, we had, I think, 4 attributes. We've simplified that down to 3. We've moved the weather effects into the feature set. And basically, so hunger and thirst remain unchanged. The new attribute that we added is warmth and body temperature, which is different from the environmental temperature. So ultra dynamic weather controls the environment temperature, but our gameplay survival attribute set regulates the body temperature of our character. And so doing some quick research, depending on your scale, if you're in Fahrenheit, a normal body temperature is 98. If it drops to 95, you enter hypothermia. And by 88, you're in a coma. So for simplification, we flip the scale and basically are converting up, not down, just from a consistency perspective with hunger and thirst. But we found it easier to just skip the scale. So basically, hypothermia will kick in somewhere along the scale as we're adding to the body temperature. So it's a little wonky, but I think it makes more sense in code to mentally flip it at the very beginning as opposed to try to flip it everywhere in the UI. From a macro perspective, this is how the systems are architected, and then we'll go over and look at it in game in a moment. But starting from the top, the game mode controls the environment, which is again ultra dynamic sky / weather, that plugin. The game mode will control the seasonality, the time of day, the weather patterns. All of the things that will impact the environment will be controlled from the game mode. Next to the game mode, we have a series of gameplay abilities that are given to the player upon initiation, and they're basically monitoring either the environment or the player to determine when to trigger certain gameplay effects. So there's a series of gameplay abilities that are by default given to the player, and they start on spawn. They will interact through a series of gameplay effects to change the hunger, thirst, and body temperature. So the gameplay abilities are polling the environment. They're determining if the environmental conditions are below threshold. If they are, they'll apply a gameplay effect to the player, or they'll remove it once conditions normalize. The UI is reading from two different sources. So it is listening to broadcast events from the attribute set to determine when you are either approaching losing health, your temperature, or your body temperature is decreasing, your thirst is increasing, or your hunger is increasing. Those are listening to dispatch events from the survival attribute. The current temperature of the environment, the season, the time of day, those are listening directly from the environment into the UI. So you'll see two elements of the UI, one listening to the environment so that you as a player know the environment conditions, one listening to your player's attributes so you know the condition of your player. To the far right, we implemented, let's take the simpler one first, a series of heat sources that the player can move into a radius and then receive warmth from that heat source. So those are done through gameplay effects that are applied and removed to characters that enter the radius of the heat source. That one's fairly simple. And then food. So the way to stave off hunger or thirst is to consume food from inventory. And so we have a new inventory fragment that we incorporated, which will allow us to set different parameters for different types of food. That calls a gameplay effect, which actually has two child gameplay effects. This is a little bit of a unique scenario where you can set up a parent gameplay effect and have it have multiple children gameplay effects so that when you apply the parent, the children are applied as well. And so we'll show you that in a minute. So that's kind of how the whole macro system is set up. Why don't we jump over in Play in Editor so you can see the results of that, and then we'll come back and we'll walk through each of those systems in sequence. All right, so in Editor, let's see. In the world, we have two heat sources, the cooking station and the campfire. We have our ultra dynamic sky and our ultra dynamic weather in the environment. And so that will give us the ability to control the weather. So let's just kind of jump in here and one more thing. So we've set the threshold for freezing to be 50 degrees Fahrenheit. So you see in the upper left corner, it's 52 degrees right now. So my character's temperature, if you look in the bottom right, I think if I do this, you can see that my temperature is not changing, but my food and my thirst is. So the first thing I'm going to do is pop open inventory and watch down here as I consume some food. You'll see that the food will immediately go up. Oh, well, I'll wait a second. You'll start to see this food blinking that I'm approaching 0, but I'm not yet losing any. Oh, now I'm losing health because we're at 0, so health is declining. If I let the thirst get to 0, it should start blinking any minute now. Now it's blinking. My health will start going down even faster. So now both effects are applying and my health is dropping at twice the speed. However, when I eat food, with a double click, sorry, you see that I got food and water, and my health has regenerated back to full. So if I eat food again, I now have full health. Let's take the, let's go to winter. We'll fire up a blizzard here. And you see that my temperature is dropping. As my temperature drops, now my body temperature gauge is starting to drop as well. So you can see that my body temperature is decreasing. And I'm going to go find those heat sources. Yeah, so I stuck them over here. So the first thing you'll note is that if I get into radius of this one, my temperature will start to rise. Oh, the day-night cycle just turned on the other one. So in fact, what I'm going to do is push time back. Okay, so if I'm here at the cook station, I need to eat food again. Sorry, I got this thing set to run pretty fast. And if I leave this, my temperature will start to drop again. And an unlit fire source will not heat the body. So you can see here that I'm not getting any heat from that source. If I go over here, I get heat again. Let's push it into the evening hours. And at the evening hour, that campfire will light up once it crosses the threshold. So let's get out here and start getting cold again. Eat some more food. All right, and once that fire is lit, if I now move into radius, you'll see that the temperature is, oh, I'm struggling. I'm right on the threshold of freezing and warming at the same time because it's 24 degrees out here in this environment. Okay, I've warmed back up. And I can go. So that's how the system's working. Basically, radial heat from fire, temperature below a certain threshold will you'll decrease. Your food and water are going to be fixed by eating food. And each of the dials has their own point where they start blinking. So the food blinks at 20% left, the water blinks at 10% left. And then I think the temperature is at 50% right now. So you can see that I'm taking damage from lack of food. Now I'm close to taking damage from water. And I'm approaching the temperature point where it'll start blinking. I'm going to eat some food. Okay, and I'm now blinking on temperature, but I'm not taking damage yet. I start to take damage on temperature at the 25% mark. So at the 50% mark, temperature blinks, and at the 25% mark, you'll start to take damage from freezing. So we should kick in that, and then we'll go back over and look at the system. All right, so let's go back over and look at the systems again. All right, so let's start by looking at the UI first, and from the UI, we'll then branch into other systems. So for the UI, we're leveraging this base material out of Lyra. So this base material, which is used for all the various ammo counters, is something that Epic developed, which exposes a lot of parameters that allows you to configure this curve, these pips on the side, which are representative of bullets in the reticle of Lyra. So we made an instance of this particular base material. And then by tweaking those settings, creating the arc range to be 100%, so it's a full circle. We took it and rotated it around 25% so that it starts at the bottom. You could rotate it to start at the top. That's perfectly your choice. We increased the thickness so that we get these pips that are thicker. That's why we took our arc thickness to 0.4. And then we're using the round count and the max rounds to determine it. So we just arbitrarily said, look, there'll be 36 pips around the circle. You can play with that number. The higher the number, the more dashes you're going to get in your circle. And then the current is the round count. So those are the two material parameters that are used as the circles or the radials are counting down. The current is counting down just like bullets being consumed, except it's actually attributes being consumed off your character. We then did a texture pack, and so this is for memory reasons. Rather than having 3 separate textures, one for each of them, we basically packed a grayscale mask of each of our icons. So you can see in the red channel we have the apple, in the green channel we have the water bottle, and in the blue channel we have the thermos or the temperature gauge. And so we're basically using that to not have to load as many textures into memory. It's an optimization technique. You can research, channel packing, but it's a great way to save on memory consumption. And then in our material, we're basically using the channel parameter to isolate which of the 3 channels we want. We have our default color, which is white, and then we have our alert tint, which is sort of this red. And then we're using this sine wave to basically flick the bottle at the appropriate moment. And then the alert state parameter turns that on and off. So that's the material layout for the center icon. The radial icon is more complicated, obviously, because it comes from that epic material that we just looked at. And then we have a widget which puts the two of them in an overlay, puts the two of them together. And that way we can, if you look to the far right, we can expose which channel mask you should use to determine the internal image. How many pips on the radial should this one be? So you could have your temperature, your thirst, and your hunger have different number of pips on them. And then at what point do we trigger the low threshold alert? So in this case, 15% remaining will start the blinking effect. And so that is set by each of these UI attributes, which are hooked in and basically able to function like that. We then take those 3 and put them in a horizontal box here and set the channel to each of the 3 different channels, set any parameters that we want to on each of those 3. And they're wired up, this entire kind of widget, because in our other video we have our conditions here, our positive and negative conditions. They're wired up through C++ to basically do the changes in the material parameters. And so that looks a bit like this, which is the widget is listening to these changes in the attribute set. So whether the temperature changes or the thirst changes or its max changes, we basically run these functions here, which will call this update attribute % for hunger, taking the new value divided by the max to get a percentage. That gets passed into the individual radials here, where we basically determine and then set the scalar parameter value. Remember I said the rounds current is the material attribute that's coming from the parent material. So we create the dynamic material here and basically change the number of pips that are highlighted. And then if we're below the low threshold, we'll enable low, and if we're above the low threshold, we'll disable it. And those are just basically down here. is alert state on for the icon, and for the radial, they're just different tags, parameters. And then if we turn them off, we set those back to 0. So this is basically a toggle, whether we're on or off, and we set it here. And so basically that's how the UI system is functioning. Moving on to the environment, we're managing the environment through a series of gameplay effects. And there are some gameplay effects that will increase your stats. So adding warmth to the body would increase, applying the food effects would increase. Hunger is going to obviously decrease. If we remove warmth from the body, that'll decrease. Rest and stamina we didn't show. We're still working on those. Thirst is a decrease, and then warm set by collars increase. So those are some of the gameplay effects that we're using. We'll talk about them in a minute. And then inside the conditions, we have a variety of conditions that could apply. We could be in a dehydrated state. So if we're dehydrated, that's when we're starting to take damage. If we're freezing, we'll take damage. If we're near a fire, we will increase our warmth. And if we are starving, we'll take damage. So 3 of those are the gameplay effects that damage the character's health. And the 4th one is when we're in radius of a fire, we apply extra warmth to the character to combat the environmental effects that are coming from the environment. The ability set broadcasts these states. So when thirst or when hunger gets all the way to max hunger, we will broadcast on starving. Same with thirst, we'll broadcast on dehydrated. And if the temperature is greater than the hypothermal temperature setting, then we'll broadcast freezing. This is the one that we reversed. Technically, we'd probably say the temperature should be below the hypothermic temperature, but for consistency with the other 2, we inverted our scale. So those are broadcasted from the attribute set. And these gameplay abilities are listening. So corresponding to those 3 broadcasts, the dehydrate ability, freezing ability, and starving ability are all listening for those events to occur, while the pole environment ability is doing the integration to the environment to determine what the temperature currently is, to determine whether it should heat or cool the body. And the listeners then apply on starving or not starving. They apply the starving gameplay effect. So this is a custom Lyra gameplay ability where in the C++ we are listening for those delegates. And then when those delegates occur, we turn around and call a blueprint node, so that we can override these 2 blueprint nodes here and expose the logic inside the editor. Now, in these cases, it's important because we're going to talk about this when we get into the campfire scenarios. In these cases, what we do is when we start starving and apply the gameplay effect, we store the handle. That is because the gameplay ability is a 1 per actor, it's instance per actor, in that I know that if I applied this to an actor, when I come back, I have a 1-to-1 relationship with my actor. And so I can just use that active handle that I've stored here in this gameplay ability to then remove the ability. And so this is perfectly fine from a multiplayer perspective because it is 1 instance per actor. And I know that the starve and the not starve are going to happen on the same actor because they're tied together. Hopefully that makes sense. So this is how we're applying the gameplay effect to reduce health. And then in the ability set, we basically are always running these listeners. So these top 3 are listening to the attribute set. This one is polling the environment. So those gameplay abilities are given to the player from the ability set. We also automatically trigger our hunger and thirst. Those are consistently running. So hunger and thirst are constantly happening. So those two gameplay effects don't need the environment to change. They just happen. So you're always getting hungry and you're always getting thirsty. So that's how we've kind of set the environment up using the gameplay abilities and the gameplay effects. On to food. Food, if we pull this up, we talked about food being an inventory fragment in the overview. Basically what we've done is created a new inventory fragment called food. In that fragment, we have our associated gameplay effect so that we could potentially change the gameplay effect by food. But this is the one that we have set up right now. We have a variety of parameters that says this food can give me instant health. It could give me instant hunger or instant thirst improvements. So it can heal me, give me instant food, instant drink. We don't have to do all three. You could only do one of the three. And it also has the ability to add over time. And so again, you can have food that would have no instant effect, but have overtime hunger or overtime health or overtime thirst, or any combination of the three and three overtime parameters. And so these all map directly to the apply food effects. And so these are the parameters that are exposed in the per food fragment. So if you have items in inventory, I just add this food concept. So in my case, the cooked meat that we were eating, it works because it has this fragment attached to it, and then it reads these parameters. Inside the code, basically when you double click on a piece of food, we're running this logic that checks and processes food. It first determines, is this a food item? And so it tries to find the food item. If it doesn't find the food item, it's not food, and therefore it doesn't trigger it. If this is valid, we then request the server. So this is happening on client. When you double click a piece of food, it then sends a request to the server to go ahead and process the food. So it passes the item instance that you clicked on. And then we had the associated gameplay effect class, which we actually don't need. So we'll go in and be removing this because it's already contained on the item instance. And you'll see that we can pull that from the code. That request server process food is basically checking that we have a valid item instance and that we have an associated gameplay, and that we once again check that we have food fragment. Again, this is where, since we pulling the food fragment, we don't need to pass that. We could have got it right here. And then it gets the ability system component. It sets up a call to a gameplay effect by this make outgoing spec. So we take our gameplay ability system component, we do a make outgoing spec, we pass it in the gameplay effect class, the level, which is just 1, and this blank context handle. So we start off with a blank handle, so this sets it up blank. We then flip it from a handle to a spec and do the set by collar magnitude. So each of these is using the tags, the predefined tags. So the set by collar food, instant health, instant food, these match exactly the food fragment. These are tags that we've added through the tag system. These are just constants that allow us to put them here. And then we pass the parameters off the fragment. So we have our instant parameters, our overtime parameters. They're all assigned in this spec as set by collar. And then finally down here, we apply the gameplay effect spec to ourself, and that triggers the gameplay effect that we had set up in this associated gameplay effect. Hopefully that makes sense. That gameplay effect is set to instant, and it has these additional effects, these children effects that we've set up. One is the food effect instant, and one is the food effect over time. And so that allows us to have the food being applied instantly and the food being applied over time by just calling one gameplay effect. So we call this one gameplay effect. It instantly executes. It triggers 2 more gameplay effects. And important is you have to check this box, which is what passes the data from the spec. So in order to get the set by caller data from this gameplay effect that we call directly to the children, you have to check this box. Otherwise, it will not copy over the gameplay spec, the set by caller tags. And then in each of these, we show we apply the various set by callers. That parent gameplay effect then has these 2 children, and these 2 children have the different settings. So the instant is applied instantly, and the overtime has duration. Instant applies a add to food, set by caller, whatever quantity we set in that set by tag. So here's the tag set by caller food, instant food. That value will apply here. Same for drink and healing. So you can have multiple in one gameplay effect. And then the other child is by duration. It will run as long as we set in the overtime duration, which was again set in that C++. And it will apply on a 1 second period for however many duration this is. It will set by caller the overtime food, thirst, and healing. So these 2 children, which get triggered through that parent, can apply different elements. And if none of these set by callers are set, or if they're set to 0, then nothing will occur. That allows you to do any combination of these 6 things on a given piece of food based on how you set up the fragment. Okay, on to the radial fire, the sort of last element of the system. These are quite simple in that we have trigger volumes around our sources of heat. As the player overlaps those trigger volumes, by the way, these trigger volumes are set to only overlap with pawns. So if you add the sphere, you can go into its properties and you can say, I think by default it's overlap dynamic. You change that to overlap pawn, and it'll only fire when a pawn is triggered. We check that we only do this on the server so that we are in control. In the case of the fire, we determine whether we're active or not. And so if we're active on the fire, then we apply warmth, and we don't need to check whether we're active. Basically, we don't need that check. We just remove fire. So when you leave the circle, we remove. When you enter the circle, we apply as long as the fire is on. Obviously, if the fire comes on while you're in the circle, we do some additional checks to make sure that you apply. And if the fire goes out, we also remove warmth from any player inside the circle. The apply warmth and remove warmth is going to get the player state because in Lyra, the ability system is on the player state. So the object that comes in from the apply warmth, we can pull from that object and get the player state. From that, we can get the ability system component, and from there we can apply is near fire. And the difference in what I mentioned earlier, in this case, when we're removing it via tag. And so we're removing the active event via grant tag because we can't use the same method we used in the gameplay ability, because I might have 3 or 4 people around the fire. And so in this case, what I want to do is when I exit, I'm going to use the tag to basically remove this character and not store a handle. So the other method would be to store the handle on the fire. However, if I store the handle on the fire, I don't know, I'd have to keep an array of all the handles, and I'd have to match up which element in the array matches which character. So it's much easier and simpler to just say, look, when I apply this gameplay effect, I'm going to apply this tag. I'm going to grant this tag. That way I can remove from this ability system component this specific one. And so it's cleaner when you are in multiplayer to use the tag removal if you've got the potential where you've got multiple players interacting with an object, in this case a fire. When you're inside a gameplay ability, it's a one-to-one relationship, so you don't need the overhead of the tag, but in this case you do. All right, so that's it for this video. Hopefully that gave you a good overview of how we put these systems together. In a couple of days, we'll package up the C++ and add it to the description like we do all our other videos. That might take me a day or two, but hopefully this helps anyone who's kind of on that path of converting Lyra over to a more environmentally based gameplay. Thanks for watching.